Hello, everybody. We're going to be going through 2018 question FRQ number 3. Before we begin, I'll share with you a little bit of some joy and happiness in my life. This is the item I got for my wife for Christmas this year. You can see that. It's a Bitmoji pillow of me. Look at that. She loves to cuddle with it because, hey, who wouldn't? So thanks for coming today. We are going to be going through 2018 FRQ number 3, like I said. And after that plankton problem, this guy is going to seem like a walk in the park. Remember, overall, when you're doing a regular year, all 6 questions, there's going to be easy ones and hard ones. For this year, I'm not really sure, but let's see how it goes. All right, so here we go. The graph of the continuous function g, which is the derivative of f. If this is me, I'd probably write this down right away in 2020 because that's an important point. Normally you have to figure that out, but it tells you. The function g is piecewise linear, so it's this little quadratic here, which is this gray piece that I outlined, and the rest of it is all little linear pieces. If f of 1 is 3, what's the value of f of negative 5? Well, if you think about it, and I could put together my thoughts here and think about the graph of f of 1 is going to be 3, right there. So now how do I figure out what's happening way over here at negative 5? Well, I'm going to go backwards in time, and the accumulation of the area, which is an integral, represents displacement or change in position. So you have your initial condition 1, which is 3, and you're going to be adding that to the displacement from 1 to negative 5. Now, there's a couple different ways to handle this. Way number 1 is probably a good idea just to flip the sign and make the lower boundary on the bottom the smaller value of the number, and then just know you're going to go in reverse time here. The other way is just, if you're thinking about these areas, the green, yellow, and blue part, just flip all their signs. The area of this green triangle, and I'm starting at 1 because that's the initial condition I knew, is 1/2 base, which is 1, times height, which is 2. Half of 2 times 1, which is 1. So if it's going forward in time, that's an area or a displacement of 1. If I'm going backwards in time, we're moving down, or a negative 1 area displacement. So the integral is important because you have to kind of show your setup here and how you're doing that. So if you have your integral in there, that gives you the point. If you just started accumulating all this area without writing out your plan and showing your integral, you wouldn't hit that point. Whenever you do an integral, solve an equation, etc., you really have to show all that work. The answer is any one of these. 25 over 2 is a simplified version. This is a no calculator problem, so you certainly can leave it like 3 minus a negative or plus 19 over 2, or you could absolutely leave it like this, with the negative in front of the quantity or distributing in the negative. Any one of these values, you can check them on your calculator, as long as they equal 25 over 2, you're going to be good. Just a quick comment, how do I get all this? Well, this blue area is this rectangle. Very simple. It's 3 times 3, which is 9. But you're going, it's underneath, so it's negative 9. But really, if you're going backwards in time, you flip it to positive that 9. That's why the minus is negative. And then this yellow 1/2 base times height is 3/2, so 1.5, and then the green, of course. So pretty simple start for letter A. Letter B, just evaluate a simple integral from 1 to 6 of g, and this is the graph of g. So here's my start, here's my end, area under the curve, figuring all this out. It's all positive, so that's kind of simple. But you do have to break it into 2 pieces right there because the function changes from a horizontal line to this parabola looking thing. So your plan is to split it up into 2 integrals. So if you did show that split somehow, you get your first point. And then this blue part, kind of easy, it's just 4. You could write this integral. That is optional because I would have went right to 4. because I would have just did a rectangle. But this part is the part that is very important because you have to figure that out. Without a calculator, you're raising this power from 2 to 3. And then you divide by the 3. So put the 2 or 3 at the bottom. That's how you get all this. Now there is not really a chain piece here. It's 1. So if the chain piece is a number, like let's say this is 3x, you'd be dividing by another 3. If it was a function, like if this is x squared, you would have to write all this out. Now, if you chose to FOIL all this out, write x minus 4 squared, and then distribute the 2 in, or pull out the 2, all of this will be fine as long as your integral is the same. And then, of course, your answer can be left however you'd like it, as long as it's equivalent to 10. So feel free to use a calculator now to check your answer. As long as you're 10, you're good. And then really pay attention to this anti-derivative, because that's the most important. All right, moving on. C. From -5 to 6, on what open intervals, if any, is the graph of f? Okay, now remember, this is the graph of f prime, or g, it says in the original. It's both increasing, so f will be increasing when f prime is positive. And then f will also be concave when 2 things happen. F double prime is positive. But I'm not going to use that because I don't have the graph or I don't know anything about f double prime. I'm going to use this piece, which is a little bit better. F prime is increasing. Now, why? Because if you're moving up a derivative, you're talking about increasing and decreasing behavior. If you're moving up 2 derivatives, you're talking about concavity. So since I have f prime, moving up a derivative is when f prime is increasing, because therefore the slope of the tangent line is going to be positive. So the tangent line f double prime and f prime. So intervals. The intervals are 0 to 1 and 4 to 6. It did say open interval, so hopefully you don't have equal 2 sides on these. They probably give that to you as long as you have 0 to 1 and 4 to 6. You can use interval notation, you can use the inequality symbols. But then the reason is the most important part. Why? Here's my plan. Because f prime is positive, and my plan is f prime is increasing. So if you look at this, here is the f prime is positive piece, and here is the f prime is increasing piece. Now, what will they do if you say, well, because f double prime is greater than 0 or positive? They won't give it to you unless for some reason you added somewhere else. I know this because of the slope of the tangent line at those points is positive, or because the function is increasing. But you do have to speak about what you have. Since you have f prime, you need to talk about how you knew f double prime was positive given f prime. And if you see that, I did all the yellows is the positive piece. Therefore, positive for f prime means increasing for f. And then I did the going up, increasing for f prime. Therefore, that's the purple part. That came up for that. And then D, find the x coordinate of each point of inflection. Okay, so here's my plan. Point of inflection definition is that f double prime must change sign. How do I know that f double prime must change sign when you're looking at f prime? That's the question. That's going to be your reason. So the answer is very simple. 4, right here. How did I know? It is right there, because f prime changes from decreasing to increasing at that point. No other times will that happen. Increasing, 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 increasing. Okay, so now we go decreasing to increasing. So therefore, since f prime changes from increasing to decreasing, your slope of the tangent line will change signs at that point. So then that's kind of your answer. And then there you go, part B. Thanks for listening. Hope you did well on this one. It is definitely more of an easy type of question. Good luck, everybody.